Alright, welcome to number 2 video. Today we're coming from an undisclosed location that is obviously not my classroom. What I'd like to do for this video is to clarify something about Charles's law that we didn't discuss, and that is the temperature. So if you look at this here and look at the volume and the temperature changes, the temperature is going from a positive degrees Celsius to a negative degrees Celsius. And if we do the calculations with Charles's law equation that we have, you're going to see that we come out to negative 10 liters for the second volume. And I don't know about you, but I'm pretty sure that we cannot have a negative volume. So, what does that mean that we do instead? So that means that we need to find a temperature system where the value can never be negative. Degrees Fahrenheit and degrees Celsius can both be negative, but Kelvin can never be negative. It's always going to be positive. It's always going to be 0 or above. 0 is absolute 0. Now, if we look, we're going to be able to change between Kelvin and degrees Celsius. It's a very simple equation, super easy. All we do is we take degrees Celsius, add 273, and that gives us our amount of energy in Kelvin. So now let's redo that calculation. So if we redo it, we have our same parameters: volume, temperature, 1. Volume 2 is our unknown, temperature 2, negative 25 degrees Celsius. But we change it over, and we end up with 298 Kelvin for T1 and 248 Kelvin for T2. Now we plug that into our equation, we do our math, we do the cross multiplication, we get 10 liters times 248 Kelvin equals X times 298 Kelvin. Then we divide both sides by 298 Kelvin to isolate our variable, and we end up with 8.3 liters. Now the question is, does that make sense? Well, temperature going down, lower kinetic energy, the pressure would change, but since the pressure has to be constant, we are going to actually lower our volume. So that makes sense. We're almost done. The next gas law kind of wraps up our single person's gas law. Gay-Lussac, what his gas law discusses is the variables are pressure and temperature. The constants are volume and number of particles. Well, if temperature goes up, what's going to happen to pressure? The fact that temperature went up means that kinetic energy has gone up. What does it say? Oh, if kinetic energy goes up, that means they're moving faster. We're going to have more collisions, and that's going to equal more pressure. But, oh yeah, so that makes sense. So we just kind of talked about our relationship between temperature and pressure. If they're going to be directly proportional like they are, like Charles's law and Avogadro's law, those two gas laws have directly proportional. One goes up, we end up saying the pressure goes up. So if temperature goes up, the other goes up. It's directly proportional. So we end up with pressure divided by temperature equals our constant. And if a pressure divided by temperature equals the constant, this is going to be our equation. So that's the end of the video. Check out the assessment.